So if you're going to tell me that magnesium gets heavier, tell me how much heavier it got. Give me the grams in here. Add some specific details. Where kids go wrong in this section is they'll write me this. They'll write, in our experiment, magnesium got heavier. Yeah. Now, if that's the case, tell me how much heavier it got. I'm going to be looking for a thing that says grams in here. It's probably going to be about, well, who actually got, how much did your magnesium get heavier? Who's got it written down somewhere real quick? Yeah?
I got heavier
Yeah?
by 100, like,
About
that's 90 grams.
80 grams.
90 grams. Okay, brilliant.
My lid broke.
Is this that and that?
No, this is the first paragraph, which is your science behind it, and then your second paragraph talks about your
Results.
results.
What is the science behind it?
Yeah.
I'm going to load back the results.
No. Okay, stop and listen. In your discussion, I expect 3 to 4 paragraphs. One will be about the science that we just talked about, and then your second paragraph in your discussion is about your results and your observations. What I want you to do is relate it to this. So we got 90 grams heavier, didn't it? Why? Why did it get heavier? Because we added what to it? If you take something and you add it to something, it gets what? Heavier. So, you are telling me that you added oxygen, and that means that it gets heavier. Okay? Why does it get heavier? Because when you add something to it, it increases its mass. Now, if you just write, we're adding oxygen to it and it gets heavier, are you explaining to me why it's occurring?
No.
So then again, I would say that this would be something that I would accept it at, but for above, I'd want to know why it gets heavier. For well above, I've written 3 words up here. And in here, I would like you, if you're going to the well above, I would like you to be considering the ratios and weights. Now, I'm being a little bit vague about this because a kid who is well above will be going away and finding a little bit of what? Their own information, yeah, and looking at them. Now, I just don't want to go say, oh, just go away and look at it. So I am going to give you some keywords that you can go away and have a look at. All right, now, this is our first attempt. So we'll be reasonably lenient around that. Yep.
What do you mean by ratio?
Okay, so basically, I'm talking about the ratio of how heavy magnesium is to the ratio of how heavy oxygen is. That's a massive hint. Okay.
Wait, can you say that again?
So magnesium, what's its atomic weight?
12.
No, that's its atomic number.
Oh.
What's its atomic weight?
24. That's 24.
24. So 24 to 16 is a ratio. So magnesium is heavier than oxygen. So how does that relate to how much extra oxygen we had? So you know how much magnesium you had, and you know how much oxygen you had, and do they match these ratios? Okay, we'll stop. Okay, so the ratio between this and this is what? 6 to 4 or 3 to 2?
Oh, is it because you divide them?
Yeah, I'm just taking a top factor. So, if we had, I don't know, a gram of magnesium, we would expect it to get another ratio of oxygen. Alright? So, I've gone a lot more detail than I intended to for that. So, that's alright. This is probably going to be a fairly large paragraph. This one is probably going to be fairly short. Okay, because like your results, you're going to be telling me how much your magnesium grew. and then you're also going to tell me what your observations were. Okay, and then trying to link them back to what we've discussed about science. Third paragraph. All these are in your what? Starting with D. Now, you could actually split this into one paragraph about errors and one paragraph about redesign if you wanted to, or you could lump the whole thing together. What were some of the errors? So, lid broke, yep. Safety flame. Now, the safety flame, when you lit it, if you looked at the bottom of your crucible, so there's your crucible, you got what along the bottom here? Soot. It's called carbon scoring or carbon soot. Now, if you think about it, if you say soot, fine, but if you say carbon soot, what have you once again given me for?
Information.
A little bit more information. Why is soot a problem on the bottom of your
It adds
crucible?
weight.
This adds weight. So, can we get around this though?
Yes.
No.
Well, there's a couple of ways we could have, but like because we have to be safe in the lab, we don't have any choice but lighting that Bunsen burner on safety flame. But what we could have done is lit it on safety flame, turned it on to heating flame, and then moved the tripod over the top of it. That all would have been safe, wouldn't it? Yeah?
That's what I would do because we don't have there.
Yeah. Now I expressly told you not to do that so that we would have a
Error.
error to talk about in our assignment, but also too something that already we can see a way in which we could redesign this experiment to get rid of this error. Everybody understand what I mean?
Sure.
Now, if you make it heavier, then you're going to affect your experiment by putting soot on it. Now, most people did it really quickly and the soot was negligible. So do we think this is a big error?
No.
But it is still something we need to talk about, isn't it?
Yes.
So, not a big error, but still there.
Surely you said oxygen was also an error. Like the air.
Yeah. So the other thing is we've got the lid open. Now, when we open the lid, what did we see?
Light.
Yeah, we saw smoke. We also saw some light, probably something we put in our observations. But when you open up that lid and smoke came out, I asked the kid, does smoke weigh anything? And they said no. But it does. Like the steam out of your kettle actually weighs something. So does the smoke off an object. Yeah, it doesn't weigh a lot though.
No.
Big error, small error?
Small.
So we would say that this is a small error. Why is it an error?
That's weight.
Yeah, so if you wrote to me, when we open up the lid, smoke comes out, this is a small error in our experiment, what's the problem with that?
Not enough info.
You
It's not
haven't
telling us
explained to
why.
me, you haven't explained why it's an error. Smoke, we might have lost some weight. Now, that smoke may be magnesium, it may be oxygen, it may be stuff that's left over in that crucible, but you still weighed it, haven't you? Now, we don't think it's a big error, but can we actually run this experiment without opening the lid? So we have to kind of just live with it, don't we? Unless, of course, we could think of some other way in which we could pump oxygen into the experiment. Well, you could.
If you
You could basically have just a hose linked to another way in which we could burn it. We don't have to always burn it in a crucible, and that could pump oxygen in. And then that way, no smoke would what? Is it worth it though?
No.
Well,
depends.
maybe not. Like we wouldn't know unless we
Try it.
yeah. Anybody think of any other errors? Who didn't get it to work?
What?
Who didn't get the magnesium to burn? There was one group. I think it might have been in the other class. The other error is how you actually put that magnesium in it. So I saw one group put their magnesium strip like this. Now the problem is, where's the hottest part of the crucible?
Down the bottom.
It's down the bottom. And so they didn't find that it worked. I saw other groups do this. Get it and coil it up into a tiny little coil. Now, that actually puts it right down the bottom of the crucible, But the problem is, if you put those two pieces of magnesium together like that, the oxygen can't get to the metal, so it didn't react. So you've only got some of that magnesium that's reacted, and for some people, if you pulled it apart, you would have actually found like magnesium versus magnesium, the oxygen can't get in there. So sometimes if you coil it a little bit, that can be an error. So coiling it too much. And this one's not near heat. Now, if you didn't have them, then that's fine. Now, someone actually got their tongs and smashed up the magnesium that was there to form a powder. Fine, because they were checking whether all the magnesium had actually done what?
Burnt.
Reacted, but the problem was, what do you think got stuck on the bottom of their tongs?
Magnesium.
Yeah, and so when I picked their tongs up, there was a little bit of magnesium oxide on the tong. That's going to affect your weight, isn't it?
Yeah.
And so this might be something that you could talk about. If you didn't do it, you could also say make sure that you don't disturb the magnesium afterwards. That's another error that we could talk about. So some of you have some of these, some of you don't. All right? So they're errors. Can you really make sure that for an error, especially if you want to move up that rubric, I'm looking for why it is an error. Okay, so this is an error because we disrupted the weight. We took magnesium out of the crucible. So don't just say an error could be that you could mush it up with the tongs. Tell me why that is an error. And then, how can we redesign it? So, if we think about it, what's a couple of ways we could make this run a little bit smoother? Could we get rid of the soot?
Yes.
Yeah, it's going to be hard to get rid of the oxygen with the equipment that we've got, but of course, we could, just look at another way to make sure that we can just get oxygen into a chamber. You don't need to tell me the exact equipment, but you can tell me if we can actually stop that lifting of the lid and still get oxygen into our experiment, then it may get rid of this small error that we've got for lid opening. So even though they're small errors, if we can get rid of them, our experiment's going to be much more accurate. The other thing that I would probably think about is that if, hang on, don't need that. You could probably look at a thing called stoichiometry if you were going to push yourself to that well above and explain what it is, just the concept of it. Now, I've talked a lot today, and I'm glad some of you recorded it. If you wish to get that recording, you can. As I said, the PowerPoint is there. Now, am I still on the PowerPoint? Yeah, excellent. If we look at the things that are in discussion, link the results back to the hypothesis. Any surprises is in here. So, who got it wrong?
What do you mean?
So, who said it was going to get low? Does it matter? No. Every scientific experiment that we do, even if it's wrong, actually can help us to move along and look at the next step. Yeah, and that's what science is about. Have we talked about everything? What happened and how do we know something happened? Yes, we have. Have we explained the chemistry that's happening? Yep. Have we linked results back to the hypothesis? Yes. Could you make it more accurate, safe and fair? Safety-wise, were we pretty safe?
Yeah.
Okay, right, I think we were, because I insisted on it. Comment on any problems or errors that you could change. So we talked about them. And that redesign paragraph is talking about how to get rid of these particular things. The last thing you'll need to do for this is a conclusion. Sum up what you found. So when we burnt magnesium, it got
Brighter.
heavier. Is that summing up? Yeah. Brilliant. The other thing is, and this is just for well above, can you find a chemical equation?
Nah, bro.
Okay, I'm going to give you tomorrow afternoon, I'm going to give you time to write this up. So that whole lesson is yours and that's it. 50 minutes. Yeah.
Can I take it over today and do it?
Sure. Okay.
I've just got this note sheet that I've been taking this whole time.
Yeah.
Good.
Oh my god.
Jack's been taking
Mine's just all over the place.
Not this rhino, the next rhino.
I don't have any diagrams, but I'll go with that.
Well, it's all over the place, but it's also like together.
It's all over the place, but it's organized. Shana, can you send me the I can start there.